Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Fikri bin Mazuki. My supervisor name is Dr. Nick Rosalyn binti Nick Muhammad Masdek. Today I want to talk about my final year project which is effect of current density on the surface and corrosion properties of deposited nickel iron alloy coating. Before go through the objective, I want to talk a little bit about electrodeposition process. So, what is electrodeposition process? Electrodeposition process is a widely used technique for the preparation of surface protective coating, which is advantage, quick, cheap, and able to handle complex geometry. Because of its magnificent attractive electrical and mechanical properties, the electroposited nickel iron coating is used to improve attractive and surface performance in various industries, particularly for attractive gadgets such as sensor inductive gadgets in the electronic industry, machine recording and power gadgets, corresponding item and also heartbeat transformer. Okay, let's go through the objective. For my final year project, I have three objectives to achieve, which is number one, to produce a nickel iron alloy coating on copper plate through the electrodeposition process. Number two is to determine the effect of current density on nickel iron alloy coating. And the last is to investigate the hardness, roughness surface and also corrosion properties of deposited alloy coating. For the scope of work in my final year project, first in this project, effect of current density was being researched to determine the true value of current density that required for the nickel iron test. This is because a good coating depends on the current density itself, depending on how many liter the solution is used. So to determine the current value of density, I have used 5 value of current density in electrodeposition process to obtain the true value of current density that are close to produce a good coating. To find the effectiveness of this process, three testing needed, which is first micro hardness, second is surface roughness, and the last is corrosion. For the micro hardness test is being utilized to assess the specimen durability after coating by using Vickers machine. Second is using 3D focus variation measuring machine surface roughness is required after obtaining 5 samples of copper plate which has been coated by 5 different current of density. This helps us to see the great surface roughness of the copper plate using a valid current density parameter. For the corrosion, salt spray test is a normalized and mainstream consumption test strategy and used to check corrosion, obstruction of material and surface coating. So for the project methodology and data analysis, the specimen that I use is thin copper plate. The size of the specimen is already fixed, so it can be put inside the beaker for electrodeposition process. It has surface area about 16.7 cm square. Before running the electrodeposition process, ultrasonic cleaner was used to clean the substrate from the specimen. High frequency sound wave of 40 kHz was used so it can remove dust, grease, debris and also other contaminants from the substrate as it was immersed for 3 minutes in a tank of distilled water that heated to 65 degrees Celsius. Okay, for the chart, we can see that to run the electrodeposition process, the optimum parameter must be obtained first so that the process can be run. The parameter which is current of density and deposition time. If we get the actual parameter, we can proceed the inspection and refine the electrodeposition. So in this part, 3 analyses were tested, which is hardness test, surface roughness and corrosion test. But if the parameter was not obtained, we must redo the process to get the actual optimum the actual parameter of current density and deposition time. So for this slide, the figures show the thin copper plate that I have used for my project, for the specimen for my final year project, which is copper plate. For the electrolyte preparation, the plating bath for the electro deposition process is the mixture of nickel sulfate, iron sulfate, boric acid and also saccharin. Boric acid and saccharin was used to act as pH buffer and grain refinement agent. So the chemical compound were prepared according to the required metabolite in table below. So for the nickel sulfate, the weight that I use is 28.1 gram. So for the iron sulfate, I use 27.8 gram, and boric acid 12.4 gram, and also saccharin I used 1.36 gram to mixture all the solution for my electro deposition process. After done mixture of all the chemical compound, the next preparation is the compound were mixed with 1 liter of distilled water in a beaker. Next, the beaker was placed on top of hot plate stirrer. Next, as the solution was heated to 55 degrees Celsius, the hot plate rotate the magnetic stirrer to stir the solution so that particle suspension was distributed evenly. The temperature of the solution must need to be maintained around 55 plus minus degrees Celsius in 1 hour so that the mixture in the beaker have been dissolved together to become a one solution. Okay, for this slide, we can see the setup for the electro deposition process. The coating process is running when the solution in the beaker have reached between 55 to 60 degrees Celsius. First, the anode was platinum titanium, whereas the substrate was the cathode. The anode used to deposit nickel iron onto substrate. The beaker has been filled with sulfate solution top of the hot plate stirrer as it required to run electro deposition process. So the platinum titanium anode were attached to the side of the beaker. The anode were clipped by crocodile clip attached to the red wire. The anodes were connected in parallel configuration to positive voltage output, which is red, to DC power supply. The black wire was then connected to negative voltage output, which is a black wire, which is connected to the copper plate that was inside the beaker. The electrical connection is visualized in the figure below. So the sample was placed in the sulfate solution by clamping and hang it using tripod stand in the lab. Then the temperature of the sulfate solution was maintained within 15 minutes at 55 plus minus degrees Celsius. The electro deposition began by turning on power supply and applying current of 1 ampere and followed by 2 ampere, 3 ampere, 4 ampere and lastly 5 ampere current of density with a different sample of thin copper plate. So upon completion of the process, the substrate is rinsed using water and dried using tissue at room temperature. To get the data analysis of this project, for the micro hardness test, the testing was done using Mitotoyo MVK-H1 by applying 500 gram load for 15 seconds. The depth of indentation should be under 1 micrometer to keep the gauge from arriving at the substrate. The thin film was not in level condition due its low thickness that lead the plate to have a bend condition. So for this condition, it's not viable to hardness testing since reversal development like a seesaw may happen on the example as the heap is applied. So along this line, the example will lays on its side as appear in figure. So for the surface roughness, the surface morphology of the coating was inspected by utilizing optical 3D focus variation measuring machine as appear in the figure. Next, the thickness of this material was washed utilizing a similar gear with different current of density. However, the micrograph was taken from cross-sectional view to gauge the thickness of coating. Numerous micrographs were taken from different areas to consider the consistency of the coating and their mean thickness. For the corrosion test, I use salt spray test which is to get the last data analysis for my final year project. For the preparation of the salt spray test, firstly, after done coating, 5 copper plates were arranged in the salt spray machine as we can see in the figure. The position of the specimen must right because based on the previous study, the specimen should facing upward when put it into the machine through the salt spray process. So the specimen should not contact each other or any metallic material or any material capable of acting as a wick. For the data analysis in microhardness test, in this experiment, viscous microhardness was used to analyze the value of hardness after done electrodeposition copper alloy process. In the table, we can see it shows the average hardness value specimen copper alloy that using 5 different current of density, which is 1 ampere, 2 ampere, 3 ampere, 4 ampere, and lastly 5 ampere current of density in viscous hardness. So for the result, we can see that the sample that using 4 ampere current of density demonstrates a higher surface hardness which is 247.36 HV compare with specimen that using 1 ampere current of density. On the other hand, there was a drop in hardness value on sample that using 5 ampere current of density but remain above from specimen that using 1 ampere current of density. The average hardness of all sample was 205.02 HV. The result show the hardness the result show that the hardness increased with increasing current density. This effect occurred due to lower stress associated with electrodeposited film. Figures show that the increase and decrease line profile for specimen that using 5 different current of density in microhardness. We can see at the graph the increase and decreasing of the line profile for the microhardness. So for this slide, we can see in the figure it shows the result in the surface roughness by using optical 3D focus variation measuring machine. In the table show the value of RA, RQ, and RZ of the specimen that using 5 different current of density. So based on the figure, it shows that the value of surface roughness that using 1 ampere is higher than value of the surface roughness that using 5 ampere current of density. This means surface roughness for specimen that using high current of density is better than using 1 ampere current of density. Next, the calculation result of coating thickness using 1 ampere current of density is 3.8 micrometer, 4.4 micrometer, and 18.8 micrometer for RA, RQ, and RZ. It showed that the surface roughness of the specimen has less effect on the coating thickness than using 1 ampere current of density. Next, the values roughness surface for specimen that using 5 ampere current of density are 2.6 micrometer, 3.3 micrometer, and 15.9 micrometer, which is lower than the specimen that using 1 ampere current of density. Lastly, based on the previous study, the surface roughness of the coating is lower than the first one because the outside layer, which pores and pancake projection, made the surface of smooth in specimen that using 1 ampere current of density is rough. For the last data analysis in my final year project, which is from corrosion test. Salt spray test was being used to test the corrosion of coating through the copper plate. Based on the table, we can conclude that specimen that using current of density 1 ampere is the best way to avoid rust after done the salt spray test. It is because there are only several rust that attach to the specimen. The situation happened because due to copper thin film, very thin and produce curve at the end of the corner, and nickel iron coating cannot fill in the area. If we compare specimen that using current density 1 ampere and 5 ampere, we can see that there are a lot of rust that attach to the specimen that using 5 ampere current of density. It means for specimen copper plate, we must use lower current of density to get a good coating at the specimen, and also can avoid rust that can attach to the specimen. Also, the position of the specimen must right because based on the previous study, the specimen should facing upward when put it into the machine through the spray process. So it can, so the specimen can produce a good result when we put it the right position. Lastly, for the original product design, the table show the 5 specimens that have done coating with different current of density. So for the first picture, it shows shiny surface at the center of the specimen. It's mean coating process that using 1 ampere current of density is compatible for this experiment for my project. So for the second picture is by using 2 ampere current of density, it shows shiny surface at the middle of the specimen, but only a half at the middle. It also produce a just small spot of burn area. For the 3 ampere current of density, the figure shown a part of rough surface at the end of left side due to current density but acceptance. For the 4 ampere current of density, there are a lot of burn mark on the specimen due to high current of density. For the 5 ampere current of density, it also show a lot of burn mark on the specimen due to high current of density. Okay, for lastly, I want to thank you to Doctor for watching my video presentation, and I have put my email and my phone number at the last slide for the Q&A. And once again, thank you for watching.